Okay, we are now going to talk about Hess's law. And Hess's law states that the overall enthalpy change, for a reaction is equal to the sum of the enthalpy changes for the individual steps in the reaction. Okay, the reason we can do this is, well, first of all, what does that mean? What it means is it doesn't matter how we get there, okay? Enthalpy is a state function. Delta H is a state function. It doesn't matter the path we take, it only matters the beginning state and the end state. So if we all start at one place, well, let me put it this way. If I leave my house, there's 3 or 4 different routes I can take to get to Chico, okay? And it doesn't matter which one of those routes that I take, I will still end up in Chico. Now, the gas I consume, the time it takes, all that will be different, but location is a state function, so it doesn't matter how I get there, just that I am there. Delta H is the same way. Now, go back and look at the Born-Haber cycle. It's a Hess's law problem. Or maybe I should say application. But remember, we took all those different steps, the sublimation, the ionization, the bond dissociation, the electron affinity, and then the lattice energy, and we just ended up with that overall net reaction. Well, that's what Hess's law allows us to do. Okay, so go back and look at Born-Haber. It will make more sense after this. So let's just do a Born-Haber or a Hess's law problem. Let's start off with a real simple one. H2O solid. Let's just say I want to know the enthalpy for this process. But I don't have any measuring equipment. I can't perform this experiment. But I have a book with some values in it. Oops, that's supposed to be solid. I can look this value up in a book. Solid to liquid. Now this up here is called delta H of sublimation. Let me squeeze that in there. This is delta H of fusion. Fusion just means melting. 6.01 kilojoules. So I can look that up. I can look this up. H2O liquid goes to H2O gas. This is vaporization. Delta H vap. That's 40.7 kilojoules. Okay. So what I can do is I can take those two equations, the blue and the green, and I can add them like I was in algebra class. And you can do this with an infinite number of equations, essentially. And that obviously wouldn't be much fun, but you can use lots of equations to do this. So we get H2O solid plus H2O liquid, and we're just keeping everything on the same side of the arrow. Let's do this. That it was up above gives us H2O liquid plus H2O gas, and we get delta H equal to 46.7 kilojoules. Okay. Well, if you look at this reaction that we have here, some things appear on both sides. Well, actually, really just one thing. H2O liquid appears on both sides. kind of like a net equation. We can cancel out stuff that appears on both sides. Cancel those out, rewrite what's left. H2O solid is this H2O gas, and the delta H of sublimation is 46.7 kilojoules. All right. In the next video, I will give you a more complicated example.